The nomenclature of aldehydes and ketones is relatively straightforward and follows the same set of IUPAC rules that we have been studying. The new things are the addition of new suffixes for each of your functional groups to identify the functional group and dealing with other functional groups present in the molecule. Now, if you have an aldehyde, remember that you have a carbonyl that's at the end of a chain. And so you have a hydrogen on one side and a carbon on the other side. When we name aldehydes, what we're doing is looking for the longest continual chain of carbons. So in this case, you've got 4 carbons, which would be butane. So we say butane, and we use the suffix al for aldehyde. And just like before, we want to name substituents like this methyl group, for example. We're going to give the chain numbers. We're numbering such that the aldehyde gets the lowest priority, or gets the highest priority, gets the lowest possible number, which is always number 1. It has to be, because if it weren't, it would be in the middle of the chain. If it's in the middle of the chain, it's not an aldehyde. So that means we have a methyl group on the number 3 carbon. So methyl for the substituent, 3 to identify its location. And notice that we don't have a number for the aldehyde because it's always a 1. So since that's redundant, we don't need to worry about it. Now for ketones, and let's say that we're using 5-carbon ketone, we do the same thing. The only differences are that we need to give the ketone the lowest possible number, and because it's not always going to be the same number, we still have to list that number. So we have a 5-carbon chain, we'd say pentanone. Ketones use the O-N-E ending for ketone. And we have to give it the lowest possible number, which is not always a 1, so we have to list it. So we have 2-pentanone, or if we use the more current IUPAC rules, pentan-2-one. Now, if we have substituents, we would list them in the front here, just like we would for the aldehyde. We're going to take a quick look now at what happens when we have other functional groups present in the molecule. And the other functional groups that we might have present are alcohols, alkenes, and alkynes. And we could have an aldehyde and a ketone in the same molecule. If we do have these mixes of functional groups, the aldehyde takes priority over the ketone, which takes priority over the alcohol, which in turn takes priority over the alkenes and the alkynes. And we would name then the ketone or the OH group as a substituent. We'd say oxo for a carbonyl, and we'd say hydroxy for an alcohol group. So taking a look at a quick example or 3, let's say that we've got a ring that has a ketone group and an alcohol in it. We're looking for the longest continual chain. That's going to be the ring. We start numbering with the carbonyl, since it's the defining functional group. It's a ketone. And since it's a ketone, we use the ending -one. And in this case, we'd say it's cyclo, pentanone. Now, in this case, since it is the number 1 and it's a ring, the ketone has to be at the number 1. We could actually leave the 1 out. However, I'll go ahead and put it just so it's not too confusing. Now we need to name the hydroxy group as a substituent. We've numbered the ketone 1, so the OH is 2, so we'd say 2 hydroxy cyclopentanone. Now, if we want to look at an example where we have both a ketone and an aldehyde group, we could look at one like this, where we also have a benzene ring as a substituent. And what we would do would be to look for the longest continual chain, which will be 1, 2, 3, 4 carbons. So we have bute. And because the aldehyde functional group takes precedence over the ketone, we'll say it's, because we have the aldehyde functional group, it's butan al. And then we would name the ketone as oxo, and the benzene ring, of course, is phenyl. Now we put these in alphabetical order, and we number starting with the highest number on the carbon that is the aldehyde's carbon is the highest priority, so that's number 1. The ketone is on 3, the phenyl group is on number 4. Now, because oxo comes before, O for oxo comes before P for phenyl in the alphabet, then we'd say 3 oxo, 4 phenyl, butanal. Let's take a quick look also at what would happen with an alkene group. So if we have a molecule that has either an alkene or an alkyne, let's say that we've got carbonyl, we've got we'll make it a double bond with stereochemistry. What we want to do is use find the longest continual chain. So that's 7 carbons in this case, which is hept. We'd say heptane when we have an alkane, but since we have an alkene, since we have an alkene, we're going to say heptene. And since our defining functional group is the ketone, -one. So heptene-one. The numbering system will give the lowest number to the carbonyl, regardless of what happens to the alkene. So 3 for the -one. The alkene starts at the number 5. And so if we put that all together, it would be hept 5-ene 3-one. Now that's according to the most recent set of IUPAC nomenclature. If we use the older set, we could also say 5 heptene 3-one. Although I think this one's a little easier because it spells out which number goes with each functional group a little more clearly. Now, since we do have stereochemistry on our alkene, we'd want to say trans as a prefix.